All right, let's talk about one of the greatest comeback stories in the entire history of science. We're talking about a single, brilliant idea that was powerful enough to unify a totally fractured discipline, but only after being completely ignored for half a century. This is the story of the hypothesis that literally saved chemistry. And it really all boils down to this one question. What if the key, the actual solution to a science's biggest problems, was just sitting there, published in a journal, collecting dust, completely overlooked by the greatest minds of the time? I mean, that sounds crazy, right? But it's not a hypothetical. That's exactly what happened. So to get what's going on, we have to rewind the clock to the early 1800s. Chemistry was this super exciting, brand new field. But honestly, it was a total mess, a state of complete chaos. It was a science divided against itself. So you had two major ideas clashing with each other. First, you got John Dalton's atomic theory, which was revolutionary, right? The idea that everything is made of these tiny things called atoms. But to figure out how they combined, he used what were basically rules of thumb, educated guesses. Like his rule of simplicity just assumed that if two things make one compound, it's probably a 1-to-1 ratio. It was an assumption. Then you had Joseph Louis Gay-Lussac, a guy who was actually in the lab measuring things with incredible precision. And he discovered that gases always combine in simple whole number ratios, like 1 liter of gas A plus 2 liters of gas B. No guesswork there, just cold, hard facts. And here was the huge problem. Dalton's elegant theory just couldn't explain Gay-Lussac's real-world results. See, if 1 atom of nitrogen plus 1 atom of oxygen makes 1 particle of nitric oxide, you'd expect 1 volume of nitrogen plus 1 volume of oxygen to make just 1 volume of nitric oxide. But Gay-Lussac's experiments showed it made 2 volumes. The math didn't add up. It was like they had these incredible puzzle pieces, but they just wouldn't fit together. And because of that, chemistry was completely stuck. So into this massive confusion steps an Italian scientist named Amedeo Avogadro. And in 1811, he comes up with an idea so simple, so elegant that it should have fixed everything right then and there. It really was the missing link. Okay, so part one of his idea is just beautiful. He proposed that if you take equal volumes of any gases, doesn't matter what they are, and you put them at the same temperature and pressure, they will always contain the exact same number of particles. He called them molecules. It's this amazing unifying principle. But this next part is what should have blown everyone's minds. He said that for all this to work, for Gay-Lussac's laws to make any sense at all, the basic particles of common gases like hydrogen or oxygen couldn't just be single atoms floating around. Nope, they had to be molecules made of 2 atoms stuck together. You know, H2O2. To us, that's basic chemistry, but back then, that was absolute heresy. It flew in the face of Dalton's core belief that an element's simplest particle was one single, indivisible atom. So let's just walk through his logic, because it's so clean. You observe that 1 bucket of hydrogen gas plus 1 bucket of chlorine gas makes 2 buckets of hydrochloric acid gas. Okay, so if Avogadro's right about equal volumes, that means 1 molecule of hydrogen plus 1 molecule of chlorine has to make 2 molecules of the final product. Now think about that. How is that possible? The only way you can get 2 product molecules is if each of the starting molecules, the hydrogen and the chlorine, splits in half. And the only way they can split in half is if they were made of 2 parts to begin with. They had to be H2 and Cl2. It was a perfect explanation. And nobody listened. It was completely ignored. So what happens when a science ignores its own perfect solution? Well, for the next 50 years, chemistry was totally lost in the woods. Without Avogadro's idea to guide them, the confusion just got worse and worse. I mean, just look at the mess they made of water. Good old H2O, right? Well, back then, nobody could agree. Dalton thought it was HO, the legendary chemist Berzelius was pretty sure it was H2O, and this wasn't just some small disagreement. Your formula completely changed the atomic weight of oxygen. Was it 8 or was it 16? They couldn't even agree on the fundamentals of the most common substance on Earth. And this problem just spiraled completely out of control. Depending on which chemist's system you followed, the atomic weights for major elements were just wildly different. Can you imagine trying to build a coherent science when you can't even agree on the mass of your fundamental building blocks? It's literally impossible. So here's the bottom line. Chemistry stopped being one science. It splintered into all these different, incompatible schools of thought. Chemists in Germany couldn't understand the work of chemists in France. Progress just ground to a halt. The whole field was about to collapse under its own confusion. But then, in 1860, everything changed.
a bunch of chemists, totally fed up with the chaos, decided to hold the first ever international scientific conference in Karlsruhe, Germany. They had one goal: sort this mess out, once and for all. This was the moment Avogadro's hypothesis was finally redeemed.
So, let's look at the timeline. Avogadro publishes his paper in 1811. For nearly 50 years, crickets, nothing. Then another brilliant Italian chemist, Stanislao Cannizzaro, stumbles upon this old paper and has a massive light bulb moment. He realizes this is the key. So he goes to that conference in Karlsruhe, and as everyone is leaving, he hands out copies of a pamphlet explaining it all. Now, Cannizzaro didn't just restate the idea. He did something much more powerful. He took all the confusing data that had been piling up for 50 years, all the conflicting atomic weights, all the weird experimental results, and he showed step by step how Avogadro's one simple idea made everything click. It just fell into place. It was the master key that unlocked the whole puzzle. And the effect was immediate. It was electric. This quote from Lothar Meyer, a guy who would go on to help create the periodic table, says it all. He said on the train ride home from the conference, as he was reading Cannizzaro's paper, it was like scales fell from my eyes. Just like that, 50 years of doubt vanished, replaced by this calmest confidence. In a single moment, chemistry had finally found its way out of the woods. So what's the big lesson here? I mean, it's a great story, but it also teaches us something really, really important about how science actually works. Specifically, it highlights the crucial difference between a scientific law and a scientific hypothesis. It's actually a pretty simple distinction when you see it this way. A scientific law, like Gay-Lussac's, is a description of a pattern. It tells you what happens. Every time you mix these gases, this is the result. But a hypothesis, like Avogadro's, is the next step. It's the proposed explanation for why that pattern happens. Gay-Lussac saw the simple ratios. Avogadro explained that the reason for those ratios was diatomic molecules. One is the what, the other is the why. The great physicist Michael Faraday said it perfectly. He's basically telling us that it's just smart to always separate the hard facts, the things we observe, from the theories we invent to explain them. You absolutely need both in science, the careful observations and the brilliant, bold explanations, but you can never get them mixed up. And here's one final amazing little twist to the story. Avogadro himself, he never knew Avogadro's number. You know, the famous 6.022 times 10 to the 23rd? That number wasn't even calculated until decades after he died, and it wasn't even named in his honor until the early 20th century. And I think that's a beautiful reminder that science isn't just about a few lone geniuses coming up with final answers. It's a long, ongoing process of people building on, refining, and honoring the ideas of those who came before. So that leaves us with one final, kind of unsettling thought. It took the smartest chemists in the world 50 years to finally see a truth that was sitting right in front of them the whole time. It really makes you wonder, doesn't it? What major scientific truths that we take for granted today are maybe just waiting for their own Cannizzaro to come along and show us a better way?